So we have 5 units in either direction of our ellipse, or in other words, we have x squared over 5 squared, or 25, just like the circle would be. And for this one, our direction up and down is 2. And so our y portion will be y squared over 2 squared, or the 4. And as an equation for an ellipse, we just say equals 1. And so an ellipse, very similar to a circle, it's just that the variation is different now. And so rather than having it equal radius, it's about the width, or how wide the ellipse goes and how tall the ellipse is. And they get their own individual number. So, going back to the theoretical, it rattles a lot. If I have the basic equation for an ellipse, I'm mixing up my x and y's, that's not going to help you. It always equals 1, and it's always going to have plus in between them. If you've got a subtraction sign, you've got a hyperbola. Have not seen hyperbolas on the ACT, so we're just going to focus on ellipses. But the other thing that we can add is the idea of the center shift, which you've already done with circles. It doesn't, if we have x squared and y squared, it's going to be centered at the origin. If we change it inside of the squared, that shifts the center of our ellipse. So if I have x minus 2 squared over 36 plus y plus 4 squared over 49. What's going on with this ellipse?
The center is at 2, -4.
Center is at 2, -4. It's about what makes it 0. And so for our center, we are at positive 2, down 4. I also want you to get in the habit of going back to the squared, because that's going to get you your number. What is the square root of 36?
6.
And so rather than 36, I want you to think of this as 6 squared. And square root of 49?
7.
So this one will be 7 squared. From our center, how wide will we go?
6 in both directions.
So we're going to go, this was 2, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And how far will we go in
7.
the vertical direction is 7. And so this one ends up being taller than it is wide, and that's fine. So we have up 4 and 3 more, and down 1, 2, 3. Rough drawing, but the concept is there. We will have our ellipse. Vaguely footballish with the brown. So that is what's going on with the ellipse. We can shift the center, we can adjust the length and width, and thankfully it's nice and logical. Width goes with x direction, height goes with y direction. So the second problem I wanted to work with you on is they say graphed in the same standard XY coordinate plane are a circle and a parabola. The circle has a radius of 3, center of the origin. That makes it nice and pretty. Oh, this is the parabola. I thought this was an ellipse. Oh well, we'll just go with it. The parabola has a vertex at -3, -2, and the vertical axis of symmetry passes through -2, -1. And the question says they intersect, or how many intersections take place. Looking at a circle and a parabola, we could have no intersections if it went all the way around. We could have one point if we had a tangent. If the parabola is crossing through, we could have 2, but we could also have 3. Yeah, that's bad drawing. But if it went tangent at the bottom, we could do 3. And then the most we could do would be 4. So, given this setup, give yourself a sketch, do what you can, but how many times will the circle and the parabola intersect?
This thing doesn't give what the axis of symmetry represents.
It gives us the vertex and the axis of symmetry. Vertex where did that problem go? Did I copy it down wrong? Oh, no, that's not axis of symmetry, sorry. Passes through. That makes a huge difference, because you're right, when I looked at it again, that was not making any sense at all. Vertex should have the axis of symmetry in it.
Do you just want to say our names when we're done?
Sure.
Yeah. Nathan. Soren.
John Paul.
Annika.
All right. So how many did you get?
2.
Not great confidence, but yes, 2. The important part of what's going on that should add to your confidence is this circle has a radius of 3. And so the farthest this circle can come over is 3 units. And it's centered at the origin. So our circle is going to be roughly here. Our vertex of our parabola is at -3, -2. And so it's down here somewhere. And it's also passing through the point -2, -1. And so this is our hint that it is crossing this direction into the circle. So my fault with the passes through, thank you for catching that. I copied it wrong. If that had been the axis of symmetry, it would have been weird. But the axis of symmetry comes from our first coordinate of our vertex, or our first point within our vertex. And so this swings to the left of the 3, which we know that's the farthest this circle can come out. And this is already crossing in, and because parabolas continue, it has to cross out again. And so that's where we get our 2 intersections. So, the people online didn't see me come in with my stack of books, but I'll show you guys. I have been combing through these things in search of ellipse problems. I found like 2. Did they show up on the October test? Did you have an ellipse? Do you know? Might have been one. Yeah, they're kind of one of those problems that exist to separate people out. If they make it too easy and too many people score high, then they feel like they didn't do their job. And so parabolas exist to stretch the limits of what shows up on the test. All right, so I keep saying parabola. Ellipse, ellipse, ellipse. Blah. Ellipse. Either. 8 units across and 10 units. Units? Can't spell. What would our equation be for an ellipse centered at -2, 8 units across, and 10 units tall?
Nathan? Or
Jump on.
So, not necessarily difficult, but easiest place to make the mistake. Did you remember to chop this in half? So, we're going to have x plus 2 squared. If it's 8 units across, we're talking about the difference in both directions will be 4 units, and it'll be 4 squared or 16. It depends on how they give you the answer looking through the multiple choice. Again, ellipses always have the plus in between the 2 of them. They will throw the options of minus at you, even though we don't really do hyperbolas. They will offer it in the multiple choice options, so make sure you have plus in between the 2 of them. And then we'd have y minus 7 squared, again, half of 10, and then squared 25, or 5 squared, depending on how they present the answer. All right, up to you. Do you want another ellipse problem, or do you want to move on and talk about the transformation of parabolas? Because that's the other thing from page 11 we're working on today. All right. ahead and talk about the transformation of parabolas because it ties in really well with the transformations of other functions. And that one shows up as well. The other thing to be aware of with parabolas is they will talk about transformations, they will talk about vertex form, but they do not ask you to complete the square. I have never seen a problem with completing the square on the ACT. SAT, yes. ACT, no. So, we will be working with the vertex stuff, but we will not be, blah, blah, blah. So, in general, for a quadratic, they also stick to vertical and parabolas rather than horizontal ones. I don't know how to express that. It's always going to be y equals. You don't have to worry about y squared. So y equals a x minus h squared plus k. So probably algebra 2, you worked a fair bit with this. What do each one of these numbers or letters, variables, do? How do they control the function? You did well with the ellipse stuff, so.
H and K are the vertex?
H and K are the vertex. And you knew in the ellipse that we had x minus h and we had y minus k. That's going on here too. They just shifted over for the sake of the function. Traditionally, this would be y minus k equals a x minus h squared. And so it's still going on, it's just changed slightly differently. But h and k are our vertex. A, it's a single number, but it gives you two separate pieces of information. The sign of A gives us our direction, and the magnitude or the absolute value of A kind of translates into slope, is the linear version of it, but really it's about the scale factor. How fast or slow is it changing compared to the parent function of just 1? If it is larger than 1, it's going to grow faster or be stretched vertically. If it's smaller than 1, it gets flattened or compressed or stretched horizontally, depending on how you see it. The reason I like this equation so much is because it's very versatile. It doesn't have to be squared. It's going to be true if we have an absolute value function. It's going to be true if we have a cubic function. It's going to be true for a trigonometric function. All of those transformations behave the same way. Changing the sign flips it upside down. The magnitude of this number tells you the vertical stretch. On this one we can get a horizontal stretch, but that one also doesn't show up on the ACT, thank goodness. This one shifts it vertically, this one shifts it horizontally. And so all of these are true no matter which function you're dealing with. They're just all functions. And so the more confident you are with that, I don't like learning the same thing multiple different times without making that connection, because then you're just using up twice as much brain power or more. All right, so we're actually going to get into the book today. You guys should be in the purple one, the Prep Plus, and we're going to, where did it go? Go ahead and go to page 338. And so this is talking about functions and transformations. So on 339, problem 2 is a pretty basic one. Go ahead and do that one on your own and shout out your name when you're ready.
What page?
339. Oh, great. He gave me the wrong book again. Never mind. That's not going to work. There's a 2003. I already still have the 2001. All right. So, have to write out. I had delusions. It says the graph of f of x equals 2x to the third, and we want to translate it 3 units right and 2 units down. What is the new equation of this graph?
Nathan,
Okay.
or
Monica? That's all.
Jump off.
So you are not dealing with the multiple choice, but based off the multiple choice, one of the troubles that they're having you anticipate making is focusing so hard on the translation that you forget. And so make sure within your new graph, I'm just going to say y, but your new graph still has the 2. And so a lot of people will drop that just because they're so focused on this and they lose things. So we're going right. Remember, our sign is opposite, so we have -3, and then 2 units down, -2. Adding in a little bit of difficulty, we have g of x is equal to square root of x minus 5 plus 3, and they ask us to translate it 4 units right and 1 unit down.
so on. Nathan,
Tessa.
or
we are going to take our function, and if you need to write it out, write it out. X minus 5 can just exist. To go 4 units right, we have to subtract 4. The plus 3 exists. To go 1 unit down, we subtract 1. And so you end up with the square root of x minus 9, and then plus 2. And so you've had a lot of practice with the formula comparing it to the parent function, but the translations can also work on something that's not the most basic function. You can still translate it the same way. So that is that. So, finally, f of x equals e to the x, and g of x equals 3 e. Describe the transformation that is happening to f of x in order to find g of x.
Or Nathan.
John Paul.
Soren.
Annika. Tessa.
All right. So, what is happening to our function?
2 units down.
2 units down.
Compressed vertically.
I shook my
Oh, is
head
that
at compressed.
toward- oh,
Why did I say no, not compressed vertically?
horizontally.
You can say compressed horizontally, they'll most likely say stretched vertically.
Stretched vertically.
Because 3 is greater than 1,
So
it will have that vertical stretch. It will look compressed horizontally, but not quite. All right, so we have 2 units down, stretched vertically.
three units right,
All right,
left, because it's positive.
'Cause
Yeah,
it's
so it does the
positive.
opposite.
yep. So, left and right, no matter what the function is. Left or right is when you change it before the operation of the function. If you change it before the absolute value, if you change it before the square root, if you change it before the exponent. Anytime you change x before the operation that is the function, it will cause a left or right shift. And anytime you tack on the number at the very end, that causes the up or down shift. All right. Please forgive my art skills, I'll be a little bit, since I was hoping to be able to use the book on this one. doing so well too. All right. So, when we have sine or cosine waves, they honestly can be either one, but they want the equation of this as a transformation of y equals sine theta. So if y equals sine theta, in this case they still use x, which I object to because it's in radians, but I guess we have to do sine x because that's what they gave us. But transformation of this graph in terms of sine of x, what is it?
Nathan.
Annika,
Oh,
B. Soren.
Right. So, the nice thing about the parabola graphs and why we spend so much time practicing transformations with them is that they're kind of obvious. There is the one vertex point that you can use as a mental anchor. When you've got these sine waves, they are repeatable, and so there's technically infinitely many functions that you could do with this. I'm going to talk about two of them just because. So, in a standard sine graph, we start at the origin and we go up and then down, right? So, we are interested in either this point or this point, because both of those are essentially the start of a sine wave. The first thing I'm going to ask you is, has the amplitude changed?
no.
No, still going to 1, so that's easy. Y equals sine. Has it been shifted up or down?
No.
No, so we don't have to add a number on the end. Has the period changed?
No.
No. And so we get to stay in the same period. We don't have to worry about a constant. All that's happening is x plus or minus number. And so if we shift it back, this would be plus. What is this distance?
Pi and a half.
Pi and half. Technically, it could also be sine of x minus, this would be 3 pi over 2. But as far as multiple choice goes, that is the one that they offer. All right. The final thing that shows up quite a bit with the functions, and so I just want to double check in with you. What is the domain of any quadratic function?
A line. Wait, no, domain. All real numbers if they're vertical?
All real numbers, as long as it's a vertical parabola, I agree. So when we have the standard parabola, y equals x squared of some form, the domain is all real numbers. And so take the gimme points. The number of times I've seen people freeze up and think, I have to find it, when it's all real numbers. It goes on forever. It goes off very fast near the ends, but it is continuing towards infinity. The same with sine and cosine. As long as it's a standard sine or cosine graph, what's the domain?
All real numbers.
All real numbers. It just goes on forever. And so save your brain power for things that you actually have to think about. All right. So, this one is not hard, but it shows up all the time. And so I just wanted to talk about it and check in with you. A circle with a radius of 5 is inscribed in a square. What is the difference between the area of the square and the area of the circle? And I'm getting tired, so I'm resorting to hieroglyphs. Which is probably good, because, oh my goodness, difference is starting to look a little bit cursive-y. I forgot the N. Reminder, keep your answer in terms of pi. Very, very rarely is the ACT going to decimal approximate.
Mm-hmm.
Nathan.
Kabir.
Monica,
Well,
Alright. So, what's the area of our square?
oh, 100 units.
100, we found it. And technically it's units.
Right.
So we have 100 units squared. The area of our circle is going to be pi r squared, or pi 5 squared, or 25 pi. And you would leave it like this. You wouldn't try to go any farther. All right. Last one, and then we will probably be packing up for the day. So, we have a semicircle. We know that it's in half, therefore, it has a radius of r inches, and the chord YZ is parallel to our radius. This is WX, just in case we need it. If the length of YZ is 25% shorter than WX, what is the shortest distance between YZ and WX in terms of R? We went for geometry challenge program to close out.
Is asking for the distance from the two segments?
Yes.
Okay.
sorry.
So the distance between the lines.
Yes,
Okay.
you can call it D. In the original, it's not drawn in, but my transferring of problem probably was less clear. So, as a reminder, how do we know what distance is? Distance is always what angle? That is your hint.
Job well.
Ooh, answer. That's fast. I don't know the answer. I would have to go back and look at my, well, I know the answer, but I can't magically generate it without going back through the work. The important part is this is a perpendicular. Radiuses can move. With circles, they're very, very fond of giving you the radius at some place that's not very helpful, but you can add it into a place that is helpful.
Annika,
Nathan.
So, in general, it's going to stay in fraction form in order to get the multiple choice answer, but we're going to take, squaring it, we get 9/4 r squared plus b squared equals r squared I feel like I'm losing a sign somewhere. Am I on the right track and just second guessing myself, or did I drop something?
You have to divide the 3/2 r by 2 because the segment is bisected.
Oh, thank you. That would do it. That's where I lost it. I knew I was getting too big, but I hadn't. There we go. So now we have 9/16, and that looks much better. Thank you. So 9/16, we're going to have 7/16 left. And so b squared equals 7/16 r squared. Square root both of them, and b equals the square root of 7/4 r. And we can assume the positive because it's a distance. All right. In general, I hope that these were at least interesting problems. It's that balance between helping your brain learn but not freaking you out. So I like this one in particular. Again, because mistakes like forgetting to cut it in half for our right triangle, I missed that one even though I did it in my work earlier. So we will go forward. All right. I will be back next week. So he has me just pulling random problems that I think are interesting. So this one today, he asked me to focus on geometry after we had finished the transformation function type stuff. But in general, is there a particular section that you would like me to pull more problems from? Would you like to see more geometry? I have ones that I call number sense that I think are kind of interesting. What types of problems would you like for next week?
I think geometry are the main ones that I struggle with still, so I think geometry is good for me.
All right, I'll aim for about half of geometry and then throw in about half of other stuff that I think would be interesting or has a good mental trick to it. And we will go from there.